All right, class. So this is week 13. One of the elements that I'm going to show you here with relation to this, if you notice, there's always an x and a y variable. And what I need you to understand is in linear regression, we're looking at the association between those two variables. Now, please listen to this part. It's not causation. Causation is different, and that is when you do an experiment, like does a leave work better than, say, aspirin? Or does, ibuprofen work better than something else? So in that case, you're taking a pill, that would be your X. And then your Y would be how soon your headache went away. That's experimentation, that's different. In this case, we're just observing something and we're looking for the association between those two variables. So how tightly this X and Y fit together will determine their behavior. For example, in this question, they're simply asking you to sketch the least squares regression line. And so basically you're grabbing a center point and you're literally clicking until you think it's somewhat in the middle, and then you basically just check. So you're guesstimating basically. If you look at all these points, X and Y's, again, this is an X and a Y right here. This is an X and a Y. Hence, you're graphing. So when you think of it, you're really looking for a line that's like this line represents some Y equal to some point or some set of points. Let's take a look in Excel. So I'm going to patiently set these up. If you bear with me, I'm going to type them in one by one. And yes, patience, my dear. In most cases, the way the program is set up in Alex for you, it will actually push the points over. But let me just share with you a few points. So I'm going to copy these over. And I'm going to pause the video meantime so you don't have to waste time watching me do this. All right, so thus far I have gone ahead and I have copied these into Excel. And what I want to show you is, for example, if I want the slope of the line, I'm going to put equals slope, and automatically this pops up. I'll double click on it and it asks you first for the Y's and then comma, and then it asks you for the X's. And that's my slope. I need also the y-intercept. So I'm just going to put a word intercept here. And let's go equals int. See the word intercept right here? Double click on it. It'll ask you for the y's. It's going to ask you for the x's. And that is my intercept. So this line is technically y equals, the line that I just drew on the left hand side is y equals negative 1.36525x plus the intercept, which is 13.74537. That is the actual value or the actual line that you see right here. The regression, which tells us, basically it's R, which is known as the correlation coefficient. And this tells us how close the points are to one another. In other words, how strong is that association. For example, on the left-hand side, do you see how this is left to right going down? We consider this a negative association. So the association being negative means that as one goes up, one goes down. If you look this way, on the opposite, if this line were flipped around, we would have a positive association, which means we either both go down or both go up, which is kind of strange to sound for a lot of students in the way it sounds. So if you go equals Corel you'll get the correlation coefficient. And it's just asking you for the array. It doesn't matter the order. So this has a negative and strong association. So we would say, in this case, there are two variables, x and y. So you would say there is a negative and strong association between the variables, whatever they are. If they happen to be aspirin and headache time reduced, or in this case, x and y, because they didn't tell us what they were. There's also r squared. This is capitalized n to the second power. And we refer to this one as the coefficient I'm sorry, having a moment here. So we would relate to this one as basically equal to this squared. So it's basically r squared. So the way we would explain this one is basically look at it as the variation in the model. So we would say in this case, the variation in the model is about 91%. You can also say about 91% of the variation shown in the model can be explained by variations in x. That's another way. So this is the coefficient of determination. Coefficient of determination. And so these are the main concepts. And by the way, I want you to also understand, if the slope is negative, so is the correlation coefficient. Keep that in mind. All right, let's look at another example here in ALEKS. I'll do one more just to refresh your memory. All you're doing here, by the way, another negative. You grab a little line, put it sort of in the middle, and then check. You have to click twice. So I like checking it. All right, so that's pretty easy. That's all they're asking for that part of ALEKS. All right, let's take a look at another ALEKS example. So this is linear relationship and a sample correlation coefficient. So this is a good discussion point for us. So here what they do is they give you 4 scenarios, you can see here. Okay, I want you to listen to how this is explained. This is a nonlinear. Do you notice it's a parabola, basically? This looks a pretty strong nonlinear. On this side, the UV, this is definitely positive. Perfect. Perfect positive. This is always positive and positive. Positive, not perfect, excuse me. This is negative, not perfect. So let's look at this. In which data set is there evidence of a strong nonlinear relationship between two variables? So that's definitely x and y. So we're going to go here. We'll select x and y as our data set. Which data set indicates the strongest negative linear relationship? Strongest negative, we only have one negative association here, and that's the WT. Which data set includes a perfect positive? Keyword perfect, that's definitely going to be up here, and that's definitely UV. Okay. And which data set has an apparent positive but not perfect? Positive and not perfect would be MN. And we check. All right, let's take a look at another one for the sake of seeing lots of different variations of this. Okay, when you see this little blob, you see WT, you see this how it's blobby? It looks like there's practically no relationship. XY is negative, not perfect. UV is positive, not perfect. MN is perfect. So let's see. Which data set includes the strongest negative linear relationship between two variables, XY? In which data set is there evidence of a strong nonlinear relationship between two variables? I don't see anything that's nonlinear, none of the data sets. Which data set has an apparent negative but not perfect? Again, XY. Looks like that's repeated. And which data set indicates a perfect, keyword perfect, positive linear relationship? It looks like MN. MN. Let's check. All right, looks like we're good. So they did use that twice, which is odd. They do give you an explanation in Alex, which you can always go through. So you could see, for example, how they interpret it. They also discuss the correlation coefficient. If you look carefully here, as you get closer to 0, you start to get no linear relationship. As you move out to either extreme, you either get a positive or a negative association. So that's that one. All right. Let's look at predictions from least squares regression line. So this one definitely will require you to pay attention to, first of all, the linear regression equation given to you here. You can see the intercept 4171. It has a negative association, so negative slope as well. So your R should be negative. You can send the data to Excel, which is very helpful. So I'm going to switch this out to our new little Excel sheet here. All right, there's nothing here that you couldn't do with your own. If you want to try it, check it out. See how that's 4171? So if I go intercept, I'll go equals int. There's my intercept. And it's asking me for the known y's, comma. Here are your known x's. See how that's 4171? And if I shrink it, I'll make it even more apparent for you. There you go, 4171. There's your intercept. You want to see your slope in action? So let's do slope. I'm going to go equals SLOP. Don't even have to go that far. It's asking me for the y's first. Known y's, comma, known x's. There you are. Negative 494, which is what you have here. If you want to shrink it like I did prior, or let's go ahead and shrink it. Negative 49. Done. That's your regression line right there. You want to know the correlation coefficient? So I'm going to say equals R. I'm sorry, equals Corel. Double click on it. It's going to ask you for the array. This is the first array. And here's your second array. There you go. Boom. So it has a negative correlation. It's moderately strong. Let's see what it asks us in the question. So this is the one part of the question it's always a little difficult for students to come to grasp with. So for these data, using selling prices that are greater than the mean of the used selling prices tend to be paired with mileages that are blank of the mean. So I'm saying, when you remember when I talked about association, I said to you, if it's negative, that means one goes up as one goes down. So they're asking you for the data used selling prices that are greater than the mean of the used selling prices. They tend to be paired with mileages that are less than the mean of the mileages. Remember, one goes up, one goes down when they're negative. According to the regression equation, for an increase of 1,000 miles in cadet mileage, there's a corresponding, so this takes us back to that equation. You see how that is negative for the slope? Decrease of 0.49. This right here indicates a decrease. Okay. From the regression equation, what is a predicted used selling price in thousands of dollars when the mileage is 23.3 thousand miles? So, okay, so we use our equation, which is equal to, I'm going to put, actually, let me escape this. They ask us for 23.3. That's like our x in a sense. So we're using y equals. So this is equal to this value plus this value times, because remember that's minus 49x. So according to this, this should be approximately 30.2, which we got right here by substituting this number in. What was the observed? Whenever they say observed, we want to go back here. And if we're looking for 23.3, according to this, is 33. Observed, you're going to look at the chart. So we're going to go with 33. Check it. Oh, we're good. All right. So all I did was I substituted in the 23 originally that they asked for x. That's what this is here. I basically use the equation and I substituted in the number. So you can always count on this value being whatever you choose, and this being your response if you set it up accordingly. So you can set it up however you wish. This is not difficult. You can do this. Total faith in you. And don't forget to change your intercept and your slope. Okay. There is an explanation in Alex. You can always look at that. That's wonderful explanation. They go through it step by step. They explain to you, like this little green box that I have here is what I did in C. They also talk you through less than and greater than. Don't forget that for part A, here, let's do another one. Let's return to the question. Let's try another one. We'll talk about it. Remember when I said to you, if it's positive association, both go up or both go down. If it's a negative association like this one has to go up, one has to go down. So, let's try another one. Okay, now the first thing I want to send the data to Excel. So it's going to open up for me a new Excel sheet. Now, if you're smart about this, look at what I'm going to do. I'm going to go ahead, I'm going to take that Excel information And I'm going to copy their 2 columns all the way down. Control copy. I'm going to come over here. It's the same amount of data points, so I'm going to control paste. I just messed up. Let's do this again, boys and girls. Send the data to Excel. There it is. Okay, so I'm going to grab the new data right here. Kind of glad I did that mistake with you. Control copy. All right, and let me tell you why. Because you're likely going to make the same mistake. So I'm just going to replace the old values. Once I do that, I want you to recognize a couple of things. The intercept for this line is not going to it's going to change because this intercept is already taking in the new information. This one is 2. It just seems identical. Okay. All right, let's see what the numbers are. So it is a negative association. Again, one goes up, one goes down. So for the data, mileages that are less than the mean of the mileages tend to be paired with prices that are, this should be greater than the mean. Second one, according to the regression equation, for an increase, according to this, for an increase of 1,000, we have a decrease. That's a negative 49. The observed value, 25.5, right here. 25.5, there's a chart. 27.5 is the answer. You could see it. It's right there. It's observed. You don't have to calculate it. In this one, however, the regression equation was a predicted used selling price when mileage was 25.5. So we're going to change our 23.3 to 25.5. According to this, it should be about 29 and change. So we have all the numbers are matching. So let's go here. Let's go 29. They want 1 decimal place, so 29.1. All right, and there you go. All right, you should be good on this one. And pretty easy to work out. All right, let's take a look at the last question. They're asking us to compute a correlation coefficient. Now, they are asking us to maybe use, let's see, if I use the data and send it to Excel. They're giving you some formulas which you could potentially use. If you want to follow the explanation there, that's fine. So actually they just want the correlation coefficient. So I'm going to go equals Corel. Double click. They want array 1, array 2. Array 1, array 2. Negative 0.83. Because how many decimals do they want? 4 decimal places. Now this could get tricky. So we may have to look at the Alex explanation. But generally speaking, I think you can get away with just... I'm going to go with that. And that was fine. The reason I'm saying that you might want to go with the other explanation is because they do give you some formulas. And there are some rounding issues with that. Keep that in mind. And that is the extent of this lesson. I think you guys should be in good shape.